Good morning. Now we are discussing about the time-independent Schrodinger equation for a free particle. As we know that the potential energy does not depend on time in many cases, and in all these cases the force acting on the particle and hence the potential energy depends only on the position of the particle, right? Hence the wave equation for such cases can be obtained as shown below. We are considering a one-dimensional wave function psi for a free particle moving along positive x direction, and that one-dimensional wave function is represented by equation 1, that is psi equals a exponential minus 2 pi I by h into et minus px, where E represents the energy and P represents the momentum, right? Now differentiating equation 1 with reference to x twice, we get this equation, that is d square by dx square is equal to 2 pi I by h whole square minus 2 pi I by h whole square. We get 4 pi square by h square, and I square becomes equal to minus 1, and as we are differentiating with respect to x, we get p square psi. P square of this whole term will be repeated, and therefore that whole term will be psi. Or rewriting this, p square psi equals minus h square by 4 pi square into d square psi by dx square. Now at speeds small compared to that of the light, the total energy is the sum of kinetic energy and potential energy. That will be equal to p square by 2m plus v. Since v is a function of x, equation 3 can be rewritten as E of psi equals p square psi by 2m plus v of psi, or E of psi equals minus h square by 8 pi square m. We have substituted for p square into d square psi by dx square, that is equal to v of psi. Or rewriting again, I am bringing all these terms to the LHS. We get h square by 8 pi square m d square psi by dx square plus E of psi minus v of psi that is equal to 0. Or d square psi by dx square is equal to dividing throughout by h cross square by 2m, where h cross is h by 2 pi. Therefore we get d square psi by dx square is plus 2m by h cross square into E minus v into psi equals 0. This is the time independent Schrodinger equation in one dimension. And this can be extended to a three-dimensional case as shown below. That is d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 2m by h cross square into E minus v of psi equals 0, and the d square psi by dx square plus d square psi by dy square plus d square psi by dz square can be written as grad square psi plus the remaining term 2m by h cross square into E minus v of psi is equal to 0. This is the time independent Schrodinger wave equation in 3 dimensions. This is about the time independent Schrodinger equation for a free particle. Thank you.